so our Friday's class was canceled, so everything got pushed today. I have a new schedule for you to hand out, printed, so that you can keep track of where we are. Okay, so you get your new schedules. You probably noticed if you went into my math lab, the due dates have all been pushed, starting with the class 15 assignment. So we're not behind at all because of that class cancellation. All right, so quiz 2, I'm going to hand out to you on Friday, and it'll be due Monday. And I have project 2 to give out to you today. Project 2 is about transformations. So you could start it now. Some of it you can do now based on what you've learned so far and what you'll learn today. But you probably won't know everything you need for transformations until after Wednesday's class. Okay? So I'll give you the project. You can have it to get started, but don't, if you get stuck, just wait until after Wednesday's class, and hopefully it'll get clearer. And I'll hand that out in a few minutes. Okay, so there is no demo for today's class. So if you go to class 15, it just starts with class activities. There's no preview exercises and there's no demo. But I do kind of want to make sure we're all on the same page heading into these activities. So I'm going to go back to the summary from the previous lesson. Okay, so page 32 here, the summary. So this is the summary of horizontal and vertical shifts, what you should have gotten out of last class. If you haven't finished the activities from last class yet, you can pick up wherever you left off. You don't have to just jump into the next class 15 lesson. In fact, I wouldn't suggest it. Definitely pick up where you last left. But even if you haven't finished yet, this is just will give you an overview of where you're headed. Okay, so if f of x is our basic graph, also known as a parent function, c is a positive real number. If I do a transformation where I do f of x plus c, how does that transform the graph of f? It shifts it how? Vertically, yeah. It shifts c units vertically up or vertically down? Up. Assuming c is a positive number, which we are assuming, right? It's upwards, right? What if I do f of x minus c? What happens? Vertically downwards. It goes c units downwards. Right? So f of x is just a fancy way of saying y. So when you add some amount to every y value, it's going to move your whole graph up. If you subtract some constant amount from every y value, it moves your whole graph down. So vertical shifting, very intuitive, right? Does exactly what you think it's going to do. Now I'm changing the x value before I apply the function f. So if I have a new function h, and it's going to be f at quantity x plus c, I'm changing the x value before I apply the function f. So that's going to shift me which direction? Left. I know. Yeah, it's weird. Yeah, it shifts c units to the left. Anytime it's definitely horizontal because what I'm changing is x. The x value is being changed, and that's going to move you left and right because x measures horizontal distance. Right? So it's definitely horizontal. It's going to shift by c units, but it's going to be left when it's positive, which is very strange. If you have no idea why and you're like, can't you just explain that to me right now? No, you have to go back and do the activities and you will see why it shifts left. Okay. When you do f of x minus c, again, it's horizontal because I'm changing the x value before I apply the function f. When you change x, that's going to move you left and right horizontally. And anytime you change anything horizontally, when you change the x value before you apply f, it's always going to do the opposite of what you think is going to happen. So that minus c, your intuition says left, right? Negative means left, but it's always going to be the opposite. So in this case, you're going to move right by C units. It is peculiar. The activities from this class, which were leading to this summary, will help you understand why it does that. Okay. All right, so now we know the rules for shifting up and down and left and right. I'm going to go walk through this last problem with you, number 27, before you go ahead and start today's activity. So this is a graph of f of x, random piecewise defined function here. I want to graph a new function that is a transformation of this one. It's going to be f of x minus 2 minus 4. Okay, and I'll graph it on the blank grid down here. So I'm going to start by labeling the coordinates of those 5 key points, A, B, C, D, and E. And then I'm going to change each of the coordinates according to what this says is happening and what this says is happening. Okay. All right, so A is at -6, 5. B is at -2, 1. C is 0, 7. D is 2, 3. And E is 4, 5. All right, so my transformation was f of x minus 2 minus 4. Okay, f of x minus 2 minus 4. All right, so that minus 2 that's in the parentheses, it's a change to x. What is that telling me is going to happen to the graph? Right, 2 is going to move to the right 2 units. How do you move -6, 2 to the right? Yeah, you're going to add 2 to the x coordinate. So I'm going to, right up here, I'm going to put add 2 to the x coordinate. Okay. And then this -4 right here, what's that going to do to the graph? Yes, it would be more generic. Down is going to move down 4 units. Yeah, yeah. So to move a point down 4 units, you subtract 4 from the y coordinate. So here I want to subtract 4 from y. So those are my 2 transformations. Okay. So add 2 to the x and subtract 4 from the y. So this is going to become -4. Add 2 to my x and I get 0. Add 2 to x. Add 2 to the x. Add 2 to the x. So those are my new x coordinates. My new y coordinates I'm going to get by subtracting 4 from each y. So 5 minus 4 is 1. 1 minus 4 is -3. 7 minus 4 is 3. 3 minus 4 is -1. 5 minus 4 is 1. So my new point, my final coordinates are going to be -4, 1, 0, -3, 2, 3, 4, -1, and 6, 1. So I just took every point on the graph of f and I moved it 2 to the right and down 4. Okay. And I found out where my new coordinates were, and now I plot them. So I've got -4, 1, 0, -3, 2, 3, 4, -1, and 6, 1. That should look like the exact same shape as my original, but moved 2 to the right and down 4. Does that look right? Good. Okay. All right, let's look at the length of the domain of g of x and f of x. So what is the domain of my original function here? F. -6 to 4. -6 to 4. And then the domain of my new function is -4 to 6, right? So it went from -6 to 4. This was the domain of f. And then the domain of g, after I transformed it, was -4 to 6. Okay, so how did the lengths of those two domains compare? They're the same. They're both 10 units long. Okay, good. All right, let's look at the range of each one. So the range of F, the smallest value on F is 1 and the biggest is 7. So it goes 1 to 7, 1 to 7. And then the range of G, the smallest Y value is -3 and the biggest one is 3. How long is the distance from 1 to 7? How many units in between there? 6. How many units from -3 to 3? 6. So the length of the range didn't change either. Okay, so length of domain unchanged, length of the range unchanged. Okay. So vertical and horizontal shifting is not going to stretch or shrink your domain or your range. That is what you're going to work on in today's activities, stretching and shrinking. Okay, so that's a really fast summary of horizontal and vertical shifting. Move on to class 15. If you are done with 14, you can move on to 15 and start looking at stretching and shrinking.